All right, guys, welcome back. This is Mr. K, code B. So this is basically end of week number 3. So week 3, day 4. So I would like to discuss another article 348, which basically pertains to flexible metal conduit. This is going to be part of your lab number 8, and that's what we're going to start off with. So when it comes to flexible metal conduit, this is a flexible part compared to your EMT. I'm assuming that most of you guys know what to do with that one. So on page 199, so please turn to your textbook page 199 and look at article 348, type FMC cable. So when it comes to FMC, so that's what we're talking about, FMC. This one stands for flexible metal conduit. This is what they are looking for, okay, or going over. So Article 348.1 talks about or cover the use, installation, and construction specifications of flexible metal conduit. Okay, and this is what basically we will be using. Okay, so again, when it comes to definition, it says a raceway of circular cross section, and then of course interconnected or locked with metal strips. So this is these are metal strips that we are using. Some of you may have already used it. When it comes to our system, you basically just bend it and try to break it. We don't have a cutter here, but yes, you can go and buy the cutter in the market. But these are the connectors that we'll be using right now. I get a coupler. So the beauty of this one, as compared to MC cable or Romex that you are used so far, is that if you run out of the conductor, the raceway, and you want to add or remove, as you know that from previous classes that let's say if you use RMC, not RMC, sorry, EMT or Romex, and especially when it comes to Romex, and if you run out, there is no splice as far as Romex is concerned. Or when it comes to MC cable or type MC cable, when you are pulling them through your system and you run out, you cannot splice it. So the beauty over here is that there is a coupler that we can basically use in this case to connect, and then I can add another piece to that one, and then that's how you can keep on going. Okay. So again, when it comes to listing requirements, again it is listed on page 199. FMC and its associated fittings, which are basically couplers and then connectors, they must be listed for the application. Okay. When it comes to the FMC in general, use is permitted. Where we can use this. Okay. If you turn to page 199 of your textbook, and there is a section called 348.10. Okay, it says FMC shall be permitted to be used in exposed and concealed locations. So in other words, where can we use this one? Well, according to the specification, it says in concealed and exposed locations. Okay. In fact, you can install this one everywhere except the items that are listed up there. Okay. So again, if you move on to article 348.12, remember 10 says this can be installed in both exposed and concealed locations, and 12 says use is not permitted, where we cannot use 348 or FMC. So first of all, it says in wet locations. So this particular one that I am holding in my hand cannot be used in wet locations because this is not properly coded. So if you really want to use something similar to this one outside or in wet locations, then you have to have a liquid tight system. Okay. So it cannot be used in wet locations, in host ways, storage battery areas, hazardous locations, as long as they are classified, exposed to material where it has deteriorating effects on the installed conductors, such as oils or gases, underground or embedded in poured concrete, and of course, where it is subject to physical damage. Excuse me. So in other words, the only place that you can use is anything which is not basically listed over here. It says exposed and concealed, but there are more spaces where we cannot use this as opposed to liquid tight flexible metal conduit. Now let's see if the very first option, it says cannot be installed in wet locations. Well, then what do we do when we are looking for wet conditions? Then there is another variation to this one, is called liquid tight flexible metal conduit, LFMC. That's the one that you guys can use outside, but this particular one cannot be. Now when it comes to the sizes, that's 348.20. The minimum size that you have this one in available is 3/8 of an inch, and the maximum size that you can use is size 4. So in fact, when it comes to NEC, so they have their own recommendation. It says FMC less than ½ inch shall not be used unless permitted by another article, or they say unless it is used through A1 through A5. Okay. If this is less than ½ inch, basically, as I said, the minimum size that you can see is 3/8 of an inch. The maximum is 4. It is possible we may ask you what is the minimum size. 3/8 of an inch. The maximum size for that one is size 4 or 4 inches. Okay. The number of conductors that you can basically pull through this FMC conduit is going to depend on a couple of factors. Number one is going to depend on the size of the pipe itself, and then it is also going to depend on the type of conductor or wire that basically we are using. Okay. So again, the minimum size is 3/8, the maximum is size 4 for this one. So it says 348.20 size minimum. So FMC less than ½ inch shall not be used unless permitted in 348.20 A1 through 5 for size 3/8. So, and if that's the case, that you can use for enclosing the leads of motors. A length should not be more than 6 feet if this is the smaller size. This is for any of the following users or uses: utilization equipment, listed assembly, so on and so forth. So in other words, if you are choosing this one smaller than ½ inch, then they are placing some restrictions on us. Okay. The maximum size I already showed you 4 inch. Okay. Now the next one is the number of conductors, 348.22 number of conductors. So how many conductors can you place? Okay. So in this case, as I stated earlier, the number of conductors that you can pull through this one is going to depend on certain factors. It's going to depend on the size of the pipe and the type of wire that basically we are pulling through. So on page 199 it says the number of conductors. So the number of conductors shall not exceed that permitted by the percentage fill specified in table 1 chapter 9 or as permitted in table 348.22 for metric designation. So I'm pretty sure if you guys may know a thing or two from code A. So when it comes to percentage fill, so if you take a pipe, so according to table 9, so let's take a little pause here. So again, if you turn to page 679 of your NEC text, because they refer table 9 in previous section, the number of conductors or cables and then cross-sectional area that you can use. Okay. So again, please go to page 679 and we'll try to figure out how many conductors you can pull basically through that one. As I said earlier, the number of conductors that you can pull through this this particular 3/8 of an inch pipe, the one you are using in lab, is going to depend on certain factors. Number one is going to depend on the size of the pipe, and then it is also going to depend on the type of the wire that we are using. So on page 679, table 1 says if you have one conductor, just one conductor, and you are trying to pull through this pipe, then you should fill 53% of the cross-sectional area. So no more than 53%. Again, it says cross-sectional area percent fill. So one conductor, what can you do with one conductor? Most probably it could be your ground. So 53% of this cross-sectional area. If you get two conductors, so in other words, if you're pulling two conductors through this pipe, then the cross-sectional area that you can fill is 31%. Okay, and if you get three conductors, I mean over two, so 3, 4, 5, it doesn't really matter, then you can fill 40% of that one. So for some reason they are thinking that if you have three conductors, they will have better filling capacity than two, and so on and so forth. So again, one conductor, 53% of cross-sectional area, two conductors, 31% of cross-sectional area, and 2 plus, more than 2, is going to be 40% of this cross-sectional area that you are allowed to fill. Okay. So this is on. Okay. Now, okay, we're going to turn to page 726. So the conductor that we are using, I think everybody knows that these three common insulation types, THH and THWN, THWN-2, and let's see how many of those conductors using different sizes we can fit through one of these pipes. So again, this is NXC that you guys may have used in code A. On page 726, I'm going to pick these three conductors, THHN, THWN, and THWN-2, and see how many of those are going to be pulled through here. So let's pick size 14. So size 14, if we are using size 14 conductor, and if we have 3/8 of an inch pipe, which is basically this one, this is 3/4. So for size for 3/8 of an inch, you can only pull 4 of these wires through that one. Those 4 conductors are going to fill 40% of the capacity, because I think everybody knows that the more wires you pull through this one, the less air gap we get between those conductors, and the hotter it gets. So the objective is that you need to make sure that when you are pulling the wires through it, you have to compensate for heat, because if there is not enough air gap, we get too many wires together. When current flows through those conductors, they heat up, and then they are sitting next to each other, and you know what happens when they start heating up over here, that they generate more and more heat. And if current has no way to escape, the heat has no way to escape, that causes problems for the insulation. So that's why we need to make sure that we have enough air gap left. This is just one very basic example. You get on a bus, it's all jam-packed, doors are closed, there is no air conditioning, no proper ventilation, and we start suffocating. So what we do, we try to run out, we try to get out, and try to breathe. But the problem over here is they don't talk, they don't speak. So when they're all congested together, then heat is being generated, and then that causes more and more problem. That's why we need to make sure that there is enough air gap over here. So if we are using size 14, and if we have 3/8 of an inch pipe, we can only pull 4 conductors. And then on the other hand, if we get 4-inch pipe, and we can have 518 of those. So again, guys, please take a look at page 726, NXC, and I'm talking about flexible metal conduit. This is what we are using right now. FMC starts off with page 725, but I'm on page 726 because this is what I am interested in through this. And if we have, let's say, 3/4 of an inch pipe, which is basically this guy, this is 3/4, not 3/8, then we can pull 22 size 14 conductors of this insulation type. So, and if we have, let's say, if we are pulling size 12, then same 3/4 inch, and the number is going to go down to 16. So as I said, the number of conductors that you can pull through each pipe is going to depend on, of course, the size. That's number one, and number two is going to depend on the conductor type. So again, if you want to know how many wires you can pull through each pipe, you can go to page 726 and try to figure out what we have. We have different sizes. So as you can see, the smallest size is 3/8. The maximum is size 4. Okay. So this is NXC, ANNEXC, page 725 for flexible metal conduit. Okay. And in fact, going back to page 726, the number of conductors for size 14 or size 12. So NXC contains the number of conductors that you can basically pull through each pipe. That covers 40% of your capacity. So everything that you do is 40%, because sometimes people ask me, okay, how is it possible? What happens to the rest? Well, if you have one conductor, 53%, 2 conductors, 31%, 2+ conductors, which is the case all the time, is going to be 40%. So the entire NXC is filled up with 40% of the capacity. So when we say, let's say size 14, for instance, 3/4 inch pipe, like this one, it says we can pull 22 conductors through that pipe. That 22 actually covers 40% of this one. So 22 is not going to fill up the whole thing. Okay? You can also pick and choose. You know, if you want to know how many wires, how many size 12, how many size 14, you can pull through that one. For that one, I'm going to actually direct you to 2 different tables that you can use, and whenever you get a chance, you can figure it out. But again, there are So what you need to do, first of all, find out the cross-sectional area of the pipe that you are interested in. And once you find the cross-sectional area, and then you go to a respective table and find the cross-sectional area of a pipe, a cross-sectional area of a conductor, and then that cross-sectional area is going to be size of one conductor. And let's say if you want to have 10, size 14, then you multiply by 10, and then you also find, let's say if you want to mix and match with size 12, and you have to find the cross-sectional area of size 12, then you multiply and add them up, and then that combination should not be more than the cross-sectional area of that one. So if we are using let's say size 14, and then if I want to know the cross-sectional area of size 14, then I have to go to one of the tables. Let me show you which table. Okay, let's talk about few other things regarding this fill-in. So again, for conduit, remember I said earlier that when it comes to 3/4 inch pipe, you can pull 22 wires, and those 22 wires are going to fill 40% only of the cross-sectional area. So there are 3 tables that are basically involved. So if somebody is interested in really finding out how many size 14, how many size 12 you can pull through a particular conduit, so what you need to do, first of all, consult table 9. Okay, this table tells us that you need 53% for 1, 31% for 2, and 40% for 2 plus. Okay, so okay, again, what I did actually, I took a little pause to give you the page number. So for conduit fill capacity, you go to table 9 on page 679. So again, 1, 53% of cross sectional, 2, 31%, 3, 2 plus or over 2 is 40%. If you are looking for conductor's area, cross sectional area of a conductor or the wire that you are using, go to table 5 on page 684, and then if you are interested in calculating area or cross sectional area of raceway, then you go to table 4 on page 680, and these areas are in inch squared. Okay, so according to one of my examples, let's say if I'm interested in figuring out that in a 3/4 inch. Okay, so how many number 14? So how many number 14 can you place through a 3/4 inch pipe? So area for size 14 for single wire is 0.0097 inch square. So again, the cross sectional area of size 14 conductor is 0.0097 inch squared from this table. Okay, because area of the conductors, and then we know that the area of the pipe for size 14 or 3/4 inch is 0.2134 inch squared. So this is the cross sectional area of this size. That's the cross sectional area from this table on page 680. This is the cross sectional area of a single conductor on page 684. So when you take this is one conductor, and if you multiply 22 by 0.0097, so you come up with 0.2134 inch squared, which is basically like this one. So anything over size anything over 22 is going to actually violate our policies. So according to NXC, you can pull 22 wires through a 3/4 inch. So again, what you need to do, you may have done this one in code A, so this could be just a refresher. Step number 1, figure out the cross-sectional area of the pipe. Okay. Well, the cross-sectional area of the pipe is on page 680, table 4. For this particular one, that came out to be 0.2314 inch squared. That's the cross-sectional area of this pipe. The next step is find the cross-sectional area of a single conductor, and then cross-sectional area of a single conductor size 14. Again, that is going to change from this page is equal to 0.0097, and now you take the number of conductors that you like to multiply. So you multiply this one by 22, and that comes to 0.2134, which is the same as the NXC, because NXC tells me that in a 3/4 inch I can place 22 conductors. But remember, that is 40% only. That is what you can do in order to calculate the cross-sectional area and then wire and conductor. So we are back on page 199, 348.22. So number of conductors. So basically you can go to page 725 and 26 and try to figure out how many through this one. But the next part, same page, it says bends. Now when it comes to bending this pipe, you need to make sure that you don't press this one too hard, or don't bend it too much, because you are going to break this. According to the NEC calculations, you can have no more than 4 90-degree bends per run from point A to point B. No more than 4 90-degree bends, which means maximum of 360 degrees. So this is what the system is calling for on page 200, 348.26, bends, number in one run. So as I said, you cannot have more than 4 90-degree bends, which is equal to 360 degrees. Okay. So when it comes to the trimming, that means after break, definitely you are going to see a very sharp piece over here, just like MC cable. You need to cut that one. There are no bushings here, but these, we have connectors like this. You just basically plug that one in, that fits in, and then that takes care of everything. But make sure that this is not pretty sharp. So when it comes to trimming, all cut ends shall be trimmed, or otherwise finished or removed, to remove rough edges. Okay, so we need to make sure that it's not damaging our conductor. Okay, the other thing is that strapping and securing. So just like type MC cable, this pipe shall be strapped within 12 inches of each box, panel board, and access point. So within 12 inches. Type MC is also MC also requires us to strap it within 12 inches of each box or panel board or whatever the device that you are connecting to, and then 4.5 feet between runs. So if you compare this with the type MC cable says 6 feet. This one is 4.5 feet between runs. So you need to make sure this is properly secured, okay, and it's not hanging down. So all of these are on page 200. Okay, so let's review one more time. On page 199, they are talking about flexible metal conduit. This is what they are talking about, this is what they are referring to, interlocked pieces. It can be installed in both exposed and concealed location or locations. In other words, you can install it everywhere except the items listed on this page 199. Primarily cannot be installed in wet locations or any places where you have gases, oils, any place that causes physical harms or damage, hoistways, things that are moving up and down, such as elevators. Minimum size 3/8, the maximum size 4. Number of bends, 4 90-degree bends per run. Must be strapped within 12 inches of each box, and 4.5 feet between those runs. The number of conductors that you can pull through this pipe is going to depend on the size of the pipe and then the size of the wire. Okay. And please read through page 199 through 200. You have only 2 pages. Okay. It's very likely that we are going to ask you on the final, when it comes to strapping, we can still use this guy up here, and then you can use tie wires. Well, we also have 1-hole straps for these. They can also be used, but primarily these are tie wires that we are going to be using. Okay, a lot cheaper. Okay. So the most important thing over here is the application, where we can and cannot use this one, and then strapping and supporting requirements, number of bends, how many wires, the minimum and maximum sizes. So let me make a couple of questions. After watching video, please answer these questions. Number 1, what is the minimum size for FMC, flexible metal conduit? Number 2, what's the maximum size for FMC? Number 3, what's the maximum number of bends per run for FMC? Another question, what is the maximum length between runs in order to strap FMC? Okay. And then true false, FMC must be strapped within 12 inches of the box, panel board, or whatever you have. Another true false statement, the number of conductors that you can pull through a pipe or FMC is going to depend on 2 things. Number 1, the size of the pipe and the size of the conductor that you are pulling through. Okay. One last thing, if you want to know the fill capacity of a raceway, how much can you fill, in other words, go to table 9 on page 679. For 1, 53% of the cross-sectional area. For 2, 31% of the cross-sectional area. For 2 plus or over 2, 40% of the cross-sectional area. Everything that you see in NXC pertains to 40%. If you know the area of a conductor, any conductor, you go to table 5 on page 684. This gives you the cross-sectional area of each conductor that you are after, size 14, 12, all the way up. If you want to know the cross-sectional area of a pipe, you go to page 680, table 4. This was one of the examples, the cross-sectional area of the conductor from table 5 on page 684. This is size 14, 0.0097 inch squared, and the cross-sectional area of a raceway is 0.2134 inch squared. Well, what we have to do, you take the number of conductors and multiply that by one size, and then compare that result with this one. If they are equal, then you are in compliance. If they are more, you are not in compliance. So in this case, you can start off with any number that you want, but in Annex C, they are telling me that I can pull 22 conductors through this pipe, and 22 conductors are going to cover 40% of this pipe because we need space for the air gap. So 22 times 0.0097, 22 conductors, each is 0.0097 inch squared, is equal to 0.2134 inch squared, which is equal to whatever we got. That means we cannot go over 22. But if I use 23 conductors or more than 22, then the cross-sectional area, collective cross-sectional area, is going to be greater than this, and that is in violation. So please read Article 348 on pages 199 and 200. Take care until then, and I think we're going to meet again soon. Take care, and until then, goodbye.